Today we're going to address application problems and look at how to set up various different types of word problems into solving things. Now, one concern that I get from students is that they look at application problems and they think, how am I supposed to figure it out? And I'm going to go ahead and spoil the mystery for you here. Sometimes in math, yeah, you're figuring it out. Sometimes you're just repeating what you've seen before. And a lot of these application problems are going to work like that, in that I'm going to show you a type of problem. I'm going to show you how to solve it. And all you have to do is remember when you see this type, this is what you do to solve. So it's not about being creative and figuring out on your own. It's about remembering which type of problem you're dealing with. Okay. Uh, Very interesting textbook I taught out of once when it talked about application problems. Gave 4 steps to master any word problem. And it kind of goes like this. It says step 1, read the question. Step 2, reread the question. Step 3, actually read the question. And it kind of hits you across the head that the first problem that a lot of students have with word problems is they just don't take the time to read and understand it. So in looking at our book, we're being told that the first thing we want to look at is identify the variable. So if we can't figure out what we're being asked to find after we've read it, we haven't read it clearly enough. And so read it again. Don't start thinking of what to do until you've figured out what the question is talking about. So if you can't re-explain it in your own words, then there's a good reason for that. Either there's a vocab word that we're not sure what it means, so go look it up. There's some formula or concept that is trying to get you to recall, so go refer to it. Or we just haven't taken the time to read and understand exactly what the question is asking for us to do. So read it a couple of times and make sure that you can re-express it in your own words. So going on to our steps, after we can clearly understand the problem and identify the variable, then we want to look at anything that we can translate into words. And sometimes we need to make a table, a picture, a diagram, or something to help motivate and inspire us. Then we want to set up the equation and then solve it and check our answer for some sort of reasonableness. Now, this is a good time to point out that you are more than welcome to use a calculator for these types of problems. I think the hard part of application problems should be the translation part, not the solving part. I think you should be able to hit buttons in the calculator to help with the numbers because you spent the time trying to figure out what the problem is actually asking for you to do. Now I use either a TI-83 or a TI-84, but honestly it's just add, subtract, multiply, and divide. So any calculator that you have that can do just the basic 4 functions will help get you there. Okay, so that said, let's look at our first type of problem, and it deals with something called simple interest. Okay, so let's read this. Let's actually look at the formula here. Simple interest refers to interest refers to the amount of money that you gain on a loan of some kind. So in the formula here we have P, which stands for principal, and that's the amount that we borrow in a loan. We have R, which stands for annual interest rate. So what percent of the money do we get each year on this? And time, or T, I'm sorry, stands for time in terms of years. Okay. So first question, suppose Juanita borrows $500 for 6 months at simple interest of 9% per annum. Now let's double check any words there. Per annum is a fancy way of saying per year. So annually, she expects to earn 9%. Now, simple interest in this case is just that. The amount of money she gets in, she's going to earn that percent at the end of the year. So if she puts $100 in, then she's going to earn 9% or $9 each year. In this case, we're dealing with $500. What is the interest that Juanita will be charged on the loan, and how much does she owe after 6 months? Okay, so there's actually 2 questions here. How much money is she going to be charged just for borrowing the money? And how much does she total owe at the end of the 6 months? Okay, so let's fill in what we know. Okay, principal in this case, the amount borrowed is 500. The annual interest rate is 9%, so we need to convert that into the decimal form. And time, we're looking at 6 months, so per year means we're looking at 6 out of 12 months, or 1/2 of a year. And so I would just type that in a calculator and get a number. And I get 22.5. So at the end of the loan, she's going to owe $22.50 just for borrowing the money. Sorry, 22.50. Okay, the second question is how much does she actually owe at the end of the 6 months? Well, the actual amount is the 22.50 plus the 500 plus the original amount that she borrowed. And so that's 522.50. It's physically how much she's going to have to give back. Candy has $70,000 to invest and wants to earn. Sorry, there's the word earn missing. Wants to earn an annual return of $2,800, which requires an overall rate return of 4%. Candy, she can invest in a safe government-insured certificates of deposit, but it only pays 2% to obtain the risky 4%. She agrees to invest some of her money in non-insured corporate bonds, paying 7%. This problem just sounds evil. Anyways, back to the seriousness. She agrees to invest some of her money in non-insured corporate bonds, paying 7%. How much should be placed in each investment to achieve her goal? Okay, so I want to clarify here. This obviously is a made-up problem, because obviously there's no guarantee that Candy would earn the money that she thinks that she's going to earn. However, we're saying that she knows for a fact that if she invests in government-insured certificates, that she's going to earn 2%, less risk, less reward. Or if she involves herself with the risque corporate, the evil corporations, she can earn up to 7%, or earn 7%, I'm sorry, not up to. So we're going on faith that those are the percents that she's going to earn. And so the question is, how should she divvy out her money of this magic amount that she's got? Okay, so in this case, I would say let's make a chart here, because we've got the corporate bonds, and we've got the certificates. Sorry, certificates, and we've got total amount that she's going to spend. So we're going to make this kind of this pretty chart here. And let's start with the idea of principal. Okay, that's the amount of money. So we know she's got $70,000 to start off with. What I don't know is I don't know how much she's going to put in each case. But you know what I can do is I can say that if she's going to put a certain amount in bonds, then the remaining amount has to go into certificates, right? Okay, then let's look at rate. Well, I know the bonds earn a risky 7%, or 0.07. I know the certificates earn 2%, or 0.02. And I know that she wants yearly to earn 4%. It's kind of balancing out between these two investments. And so her interest, and this is, we got time. So in each case, we're looking at a 1-year investment. And so the interest that she would like to earn, well, if you remember, I equals PRT, so we're just going to multiply those three quantities together. So the interest for bonds would be 0.07B sorry, 0.0, we'll clear 0.07b. The interest for certificates is 0.02 times 70,000 minus b. And total is the 4% of the 70,000, which coincidentally happens to be the 2,800 that they already gave us. So what type of equation can we set up from this? Well, we know that the amount from one investment plus the amount of the other have to equal the total. So if I take 0.07b plus 0.02 times 70,000 minus b, that all has to add up to 2,800. And at this point, we have a nice, lovely equation that we can just go ahead and solve. And so I would have your calculator handy here for this. So from here, I would want to distribute the 0.02 in. So 0.07b plus 0.02 times 70,000 is 1,400 minus 0.02b. And I notice that I can combine like terms with those two. So 0.07 minus 0.02 is 0.05b. And I also notice that I can subtract off 1,400. So I get 0.05b equals 1,400. Divide, and I get b is 28,000. Okay, so that means the bonds have $28,000 in them, and the certificates have to have the 70 minus the 28, so I just want to subtract those two, and that's where I get 42,000. So that would be the two amounts that would achieve Candy's particular goals. The next type of problem we're going to address are what are called mixture problems. These are where we're combining different percent solutions or different priced items into a combined mixture of some type. So let's kind of jump in here with the first one. Manufacturer of soft drinks advertises their orange soda as naturally flavored, although it really contains only 5% juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to conform to the new regulation? Okay, so what we've got here is we've got 3 different containers of juice. So I want to take the original amount, add some new stuff to it, and I'm going to get an even more of the third amount. Well, what do I know about each of the containers? I know that this first container has only got 5% juice in it. The one that I'm adding stuff to is going to be 100% pure. That's what pure means, is that's 100% of the actual whatever juice. And that the third container is going to have 10%. Well, do I know how much of each type there are? Well, that last sentence, how much pure orange juice must the manufacturer add to 900 gallons? So in this first one, there's 900 gallons of the 5. There's an unknown number of gallons of the pure stuff that I'm adding, because that's the question, is how much of that pure stuff do I add to get it down, or to give it up to 10%. And then from here, I would have 900 plus the original gallons of the total. Okay, so what I can do then is I can set up what's called the amount of juice equation. So of the 900 gallons, it's kind of a scary thought to think about, how many of the 900 gallons are actually juice? Well, that's that 5%. So if I go 0.05 times 900 plus x times, well, the 100%, if I convert that into a decimal, that's just 1. And then 900 plus x times 0.1, or the 10%. Okay, so then let's do some multiplying here. 0.05 times 900 should give me 45, and that's obviously x. If I distribute that in, 900 times 0.1 is 90 plus 0.1x. Okay, then I'm going to take this whole party over here. Let me write that out. 45 plus x equals 90 plus 0.1x. Okay, so what I'm going to do then is I'm going to subtract 45 on both sides, and I'm going to subtract the 0.1x from both sides. Okay, so the 45's gone. The 0.1 has moved. What is x minus 0.1x? And that is 0.9x, and 90 minus 45 is 45. So then from here, I just want to divide by 0.9. And again, go to the calculator, and I get x is 50. So if they add 50 gallons of the pure stuff to the 5% stuff, that will be enough to raise the standard to 10%. All right, this also fits under the identification of a mixture problem, so hopefully you kind of see what I mean by this. Problem goes, the manager of Starbucks decides to experiment with a new blend of coffee. She will mix some grade B Colombian coffee that sells for $5 per pound with some grade A Arabica, I don't know how to say that, I don't drink coffee. Arabica, a coffee that sells for $10 per pound to get $100 in the new blend. The selling price of the new blend is 7, and there is no difference in revenue between selling the new blend and selling the other types. So again, sort of a manufactured problem in that they're not changing the price to make a little bit more money than they were. They're saying, we just plan on making the same profit. How many pounds of the 2 grades of coffee were used? Okay. Well, so let's kind of, again, think about, we've got 2 different containers that we are mixing together to make a larger container. Okay. I know that the grade B, so we'll kind of call that B, sells for $5 per pound, and the grade A sells for $10, and they want the mix to come out selling for $7. Okay. Do I know how much of each there are? Let's see. We don't know. So we don't know this. So there's X pounds of it. Do we know grade A? Sells for 7. Okay, so this 100 comes over here. So they're saying that the new blender is going to be 100 pounds of it. Okay, so if I say that there's X pounds of grade B, it's how many of the 100 would there be grade A? That would be 100 minus X pounds of it. Okay, so and from here then, and I'm saying that I'm making the same amount of money, so I want to multiply the 2 quantities together. So hopefully you kind of go, okay, that's why it's a mixture and it's similar to the previous problem. So I'm going to multiply these 2 quantities together. So 5x plus 10 times 100 minus x equals 7 times 100. All right, we're going to distribute. So 5x times plus 1,000 minus 10x equals 700. And we'll bring this problem over there. All right, so 5x plus 1,000 minus 10x equals 700. Okay. Well, already I can see there's like terms there. So negative 5x plus 1,000. And then I'm going to subtract off 1,000. So we get negative 5x equals negative 300. I want to divide by 5, or negative 5, I'm sorry. So in this case, I get x equals 60 pounds, or 60, I'm sorry, so x equals 60. So for, based on the fact that I said the grade B, so grade B, sorry, grade is a letter E at the end, isn't it? So the grade B, there's 60 pounds of it, which means grade A, we said was 100 minus x, so 100 minus the 60 would be 40.